So starting with the original f of x, what's the transformation? So notice that I'm largely ignoring what the f of x is now, because really the transformations have nothing to do with the original f of x. What we do to the transformation is all on the outside and inside of the notation. So first thing is we want to identify outside and inside. So there's my outside transformation, and here's my inside transformation, and I have two things going on the inside. Okay, so I'm going to describe my vertical first. So my change in y. My change in y is pretty straightforward. It's going to be a vertical flip. Okay, so it's only one change. It's a vertical flip. So that's pretty straightforward. The change in x, now we have to be careful because the change in x, what I see in the notation, is the opposite of what I'm actually going to do. So instead of timesing by 3, I'm going to compress by 3. Instead of minusing 5, I'm going to go right 5. The order matters, so I just want to make sure that I get it in the right order. So my notation is backwards from what I want to do. So I'm just going to solve for this embedded x. So I get plus 5 first, and then divide by 3 last. So I'm going to shift first, compress last. And this is what I'm actually going to do, and this is what I'm going to describe. So it's going to be horizontal shift right 5 first, and then it's going to be a horizontal compression by 3 or by 1/3. Compression by 3 or compression by 1/3 means the same thing. So this one here is a lot's going on. But as long as we identify outside and inside and do it in the order that we need for the green or the outside and the opposite order for the red, we're going to be okay. So again, I always like to start with the y. Now you may want to start with the x's, but I like to start with y's because y's are easy. Okay, so I'm going to have, looks like here, I'm going to have my original y, I'm going to minus 1 first, times by 2 second, plus 2 last. Now some people like to expand the brackets and combine like terms, and though they don't have as many transformations to describe, and that's perfectly fine. If you want to do that, go ahead. But I'm just going to describe as it is, okay, the way it's written algebraically. I'm going to do vertical shift down 1. So I'll just write minus 1. It's going to be vertical expansion by 2. Okay, that's going to be this 2 here, and then I'm going to do a vertical shift again. This time I'm going to do a vertical shift up 2. Now, some of you may see this, but in the end, it's actually this minus 1 expanding by 2 makes really minus 2, and the plus 2 actually cancels out. So if you actually simplify this expression, you'd only have one transformation. And that would be perfectly fine if you describe this with just one transformation, okay, of expansion by 2. However, if you don't want to, you can always describe it this way. They are all correct descriptions of the transformation. If it's algebraically correct, it is the correct graph. Okay, so x's, my change in x. Okay, this is my notation. I need to undo that notation. I know I have a expansion by 2, a horizontal flip, shift to the right 5. If you are one of those people who know a factored form, you may look at this and say, well, I know this is expand and flip first, shift last. But let's just double check here and make sure that's actually true. I'm just going to undo this using algebra just to see exactly what all my backwards looks like. So if I get rid of the minus 1/2 first, I'm going to get times by negative 2 first. Yeah, so sure enough, the expansion by 2 and horizontal flip did happen first. And then to get rid of the minus 5, I do a plus 5 last. Okay, so then that is my expand, flip first, shift last. This is kind of what we like to see later on. Okay, in fact, we're going to try to get things into this factored form in the notation when we can. So the first thing is then, it's going to be a horizontal flip. It's a horizontal expansion by 2. Okay, and again, these could be reversed because algebraically it doesn't matter which one happens first. But what has to happen last is a horizontal shift to the right 5 last. So there it is. I've gone from notation to description. I had to do things backwards. This is to solve. This is the opposite now. Instead of going from the notation to description, I need to go from the description back to the notation. However, the process is the same. Going backwards is still the same process. So I want to do my y first. I'm going to do my y's first. I'm going to write my y out. So there's my green. So my new y is going to be, it's going to be a vertical expansion of 2 first. It's going to be a vertical flip second, and up 3 last. Okay, so there's my y. So when I write my function notation, it's going to be -2, and then I'm going to have my original f of x, some x transformation, which doesn't have any interaction with the y transformation, plus 3 on the outside. So there's all my vertical transformation. It's in function notation. I just do it exactly what I have here. My x's. Okay, so my x's, this is my do part. It's not what I'm going to put into here. That's not what goes in here. I'm just going to write out what I'm going to do. I'm going to go to the left first and then expand by 2 last. So I got to put brackets in to make sure that that happens last. My notation is just doing the opposite of this. So I'm going to divide by 2 first, and then I'm going to go +1. And that gets me back to my old x. Now this is exactly opposite of what I really want to do. That's opposite of what's said here. That's because I undid this, solve for the other x. But that's exactly what I want in my function notation. Okay, my function notation is the opposite of what actually happens. Okay, so I don't want this expression. That's not the one I want. Okay, this is the one that goes into my function notation. The expression that's done completely backwards.